Hello students, today we will continue video 4. Here we will study about pressure in fluids. First of all, in the previous video we have studied about pressure. That pressure is force upon area. The unit of pressure is Pascal and 1 Pascal is equal to 1 Newton per meter square. Okay. There we have studied different examples of pressure in solids. Today we will continue the topic with fluids. So what are fluids? Fluids, anything which can flow, and liquids and gases can flow. So therefore both liquids and gases are regarded as fluids. So we will study how pressure is exerted in fluids. All the liquids, as you all know, they exert pressure at the base or the bottom of their containers because they have weight. So anything which has weight, it will put pressure when the force is being getting applied on a particular area. Okay. So by seeing the simple diagram, you can see there are two glass tubes here. In A1, there is nothing kept. A pipe is attached, to it a balloon is attached. Here also a balloon is attached here, and in jar B, tube B, the water is there. So you can see here the balloon is bulged here. Why? Because of the water. Water is exerting pressure on the sides of the container, and due to that pressure the water is reaching to the pipe, and through the pipe the balloon has got bulged. In A figure you can see water is not there, therefore the balloon is not bulged, it is deflated. So this activity proves that liquids exert pressure on the walls of the container. Okay. After that, next thing, this is activity 5 from your textbook, says that liquid exerts same pressure at same depth. Here you can see the container is having water and there are 3 holes. The holes are at same depth, means the height is same. So you can see the same amount of water will ooze out. Why? Because same pressure is exerted at the same depth. If we change the depth, then the pressure is going to change. So let's see how it will change. Just now I told you, at same depth it will have same pressure, and at different depth. You can see here there are 3 holes. Okay, 3 holes are there in this figure in the jar. So it can be seen that from the lowest hole the water is reaching to a farthest level. From here the distance is more, the water is going to a greater distance. From top hole, less than, but greater is it's here also. And from the top, the first hole, which is at a greatest height, the distance covered by water that is coming out is less. So this shows that pressure of water is greatest near the lowest hole. The hole which is lowest, the pressure of water is greatest there, and pressure of water is least at the hole which is at the top. So what we inferred from this activity, that pressure due to liquids increases with depth. If you increase the depth, the pressure will be more, and if we go to heights, the pressure will decrease. Okay, same activity is here also. Just to give you a more clear picture, I have added this. Okay, what has to be done? 3 holes to be made of equal size, and then you will put water, and then you will see the water which is coming out. The water which is coming from the lowest hole covering a greater distance, and water coming out from the topmost hole, the distance covered is less because pressure increases with depth. Okay, the same activity is here also. As we increase the depth, the pressure will increase, and at the same depth the pressure will be same. There will be no change in the pressure. Okay. Now next topic that we have to study is atmospheric pressure. So what is atmospheric pressure? Atmospheric means air, and pressure exerted by air is called atmospheric pressure. So let's see what actually atmospheric pressure is. Atmospheric pressure is the pressure exerted by air on the surroundings ठीक है. First thing, the pressure that is exerted by air is atmospheric pressure. Then the relations that has to be understood is, it is high in cold areas, it is low in warm areas, it reduces with altitude. Just now we discussed that if the depth is decreased, the pressure will also decrease. Okay. The instrument that is used for measuring atmospheric pressure is a barometer or a manometer. So, as just now I have told you, it is the pressure which is exerted by the weight of air present in the atmosphere is called atmospheric pressure. But have you ever observed that, do you feel this pressure? Air is exerting pressure on you. Can you feel that pressure? No, you cannot feel that. Why? Because our body, it contains blood and several other things. So these are also exerting the pressure, and both the pressure nullify each other, means they cancel each other, and therefore we cannot feel the atmospheric pressure with this. Okay. Some activities I would like to make you clear with atmospheric pressure is, suppose if you take water in a glass and invert it over a piece of cardboard, it gets stuck. The water do not comes out until you hold it. You are putting pressure from your hand. Okay. So what happens is there, because from the lower side of the cardboard, the pressure is being exerted by the atmosphere, and from the top, the force is being applied. So therefore, the water do not comes out of the glass when it is inverted. As soon as you remove your hand, the water will come out, because there is no force due to the weight of the hand. Some more example, how the person is able to suck a straw. The pressure becomes low here at the top, and what will happen? The atmospheric pressure from outside, which is higher, will force the water into the straw, and consequently it reaches to the mouth. So here also atmospheric pressure is there. In rubber sucker also, you must have seen, if you stick a rubber sucker and then try to remove it, it do not comes out easily. This happens why? Because the suckers stick to the surface because of the atmospheric pressure, and when you are pulling it, the applied force should be larger. It should be larger than the atmospheric pressure. Then only it will come out, else it is not going to come out. Here again, the rubber sucker is getting stuck due to atmospheric pressure. You can see a more clear science related to rubber sucker. Now this is the rubber sucker. This is the flat surface on which it is getting stuck, and it is not that flat, it is round in nature. So what will happen? Air is having a low pressure here, and here also the atmospheric pressure is acting on it, due to which it is going to stuck on the flat surface. Okay. Now we come to barometer. Barometer is a device to measure the atmospheric pressure. It consists of a long glass tube, and it has a mercury in it. You can see here, it is vacuum at the top, mercury is there, and mercury rises up. Okay, and this scale, whatever the level of mercury is, it will tell you the pressure. Same concept is used for measuring your blood pressure. The common machine which was used earlier days, this was there. They use mercury, and the level of mercury tells the blood pressure also. Okay, greater the atmospheric pressure, it pulls down on mercury, and then the level can be calculated. Manometer is again a device that is used for measuring the liquid pressure. Here a comparison is being made. Okay, so what happens here? The mercury, again it is filled in, you can say, U-tube kind of a structure is there, where the liquid mercury is filled and the pressure is applied on the tube, and the given pressure can be calculated from the unknown one. You can see here the atmospheric pressure, it is here, it is calculated, its value is fixed and measured is kept here, and then it is calculated by making this as an inference. Okay. So this completes your chapter. Here we have completed force, pressure, atmospheric pressure. All the things have been completed. Thank you.